Welcome to this explainer. Today, we're tracing a highly sensitive, multi-tenant request chronologically through AI Fabric's deterministic security gates. If you're building AI workflows in Java and Spring Boot, this is exactly how we lock down your data boundaries.
So let's jump right in. AI Fabric acts as the core orchestration layer for your Spring Boot applications. And what we're really focusing on today is how it protects your apps before the language model ever sees a single byte of data. We're going to follow a request from a multi-tenant support knowledge assistant, one that's serving both tenant A and tenant B, to see exactly how these boundaries are strictly enforced in practice.
To get this right, we really have to fundamentally shift our mindset. Prompt engineering is basically just asking an LLM nicely to keep a secret, right? Or telling it, hey, please don't mention this other tenant. But an LLM literally cannot repair a security boundary after private evidence is already sitting in its context window. It's too late. Instead, we have to rely on deterministic gates. We're moving from asking the LLM for a favor to applying hard, fast policy so it never even gets the secret in the first place.
Here is our roadmap for the request lifecycle. We're going to hit security before AI intelligence, request access and policy, tenant-safe evidence retrieval, authorizing AI actions, processing and protecting PII, and finally, output sanitization and testing.
Section 1. Security before AI intelligence.
Right, so this is absolutely the most critical principle. Security must precede intelligence, and the bedrock of that is identity. You have to build the canonical identity from verified Spring security authentication on the back end. Never, ever trust a client-supplied ID. A browser sending an X-tenant ID header, that is inherently untrusted. AI Fabric carries the context, sure, but your application establishes the absolute truth at the HTTP boundary way before anything reaches a generation provider.
Section 2. Request Access and Policy.
Now, as the request actually hits the core orchestration pipeline, it faces some serious gates before intent extraction even thinks about happening. First up is the security analysis step. This evaluates incoming threats and IPs to just block malicious actors right at the door. Then, the access control step kicks in. This ensures the caller is actually authorized to enter this specific AI workflow at all.
The real linchpin here is your entity access policy. It evaluates that trusted authentication context we just built, and it must act as a strict allow list. It has to be fail-closed, meaning you deliberately deny missing identities or cross-tenant contexts rather than defaulting to some optimistic grant. This gate essentially answers the question, may this caller even enter the workflow? Now, it doesn't authorize specific database records just yet, but it's the critical first hurdle.
Section 3. Tenant-safe evidence retrieval.
You know, tenant-safe retrieval actually begins way back when you first save your data. It absolutely demands that you attach stable metadata tags to documents during indexing, something like a reviewed positive flag, maybe visible to user equals true. So when a search happens, your app explicitly constructs strict metadata filters in the back end, completely derived from that trusted context. AI Fabric doesn't just invent these filters. Your code builds them to enforce the boundaries before ever hitting the vector provider. But of course, we don't stop there. What if a vector provider returns a weird or overlapping result? You have to implement defense in depth. Your application should verify the returned metadata, actively dropping forbidden records before they ever reach the prompt or the citation's payload. Basically, if a record for tenant B somehow sneaks through the vector search, it gets completely annihilated right here, raising a hard boundary failure.
Section 4. Authorizing AI actions.
Let's transition from just retrieving information to actually taking action. What if our user asks the AI to update a support ticket or issue a refund? Well, a user allowed to ask questions isn't automatically allowed to execute transactions. You have to use the action allowed annotation on your handler to recheck state-sensitive rules. This evaluates operation-specific authorization against true object ownership, and crucially, it happens before any pending confirmation is even created. You never invite a user to confirm work they simply aren't permitted to perform.
Section 5. Processing and Protecting PII.
So what happens if our user includes highly sensitive data in their prompt, say an email address and a social security number? AI Fabric handles this, but keep in mind, the PII capability is explicit and disabled by default. A privacy-sensitive application has to turn it on and choose a mode: pass-through, detect only, or redact. The default patterns cover common shapes like SSNs, emails, phone numbers, and credit cards, plus you can easily drop in custom domain detectors.
This is exactly where AI Fabric's deterministic ordering really shines. Down at pipeline order 30, which is before intent extraction or vector search even wakes up, the PII detection step intercepts the raw input. If you're in redact mode, it masks the SSN and email immediately. This ensures that downstream LLMs and embedding providers only ever process a safely masked query.
To maintain strict privacy, the system defaults to keeping that original payload hidden. You should never expose raw payloads in routine results. However, if your specific compliance requirements demand recoverable text for auditing, you can deliberately enable protected storage using optional AES encryption, obviously with a securely configured secret.
Section 6. Output sanitization and testing. Okay, so the request was retrieved safely, actions were verified, and PII was masked, but we still need a final exit gate. The response sanitization step scrubs the generated answer, nested results, and the client payload right before delivery. Also, for highly sensitive requests, you can use the never_persist mode. This ensures transient workflows bypass backend recording entirely, keeping raw, off-the-record input completely out of your chat history and logs. Now, this failure matrix here, this serves as your ultimate release checklist for deterministic negative testing. Because real security claims require negative tests, you have to actively test a missing policy to guarantee it fails closed. You test overlapping searches to prove cross-tenant leakage is mathematically impossible. Submit an SSN just to verify it gets redacted downstream. These deterministic tests are your real release gate, not just a successful happy path demo.
Ultimately, this architectural partnership is perfectly defined. AI Fabric provides the deterministic pipeline gates, the PII reduction, and the response sanitization. Meanwhile, your Spring Boot application remains the absolute authority on authentication, domain policy, and tenant semantics. AI Fabric coordinates the boundaries, for sure, but your code dictates the truth.
I want to leave you with this final, somewhat provocative thought. Front-end masking is an illusion of security. If your React component simply hides a leaked tenant B ID from the user's view, the data leak has already occurred on the back end. It's too late. True multi-tenant privacy is only achieved when forbidden evidence never leaves your back-end boundaries in the first place. Apply your policy before intelligence, rely on deterministic gates, and prove it with rigorous back-end tests.